Tonight's speaker is Jen Bell. She's with ADF&G, and she's the researcher that leads lots of research on important fish and other invertebrates, or fish and invertebrates in Norton Sound. And this was an exciting thing for me, this survey, and I'm really glad Jen's going to talk about it, because all the other, 2020 was the COVID. Research was dead in the water, canceled, verboten, nobody could do it. All the big surveys, the big NOAA fisheries surveys, some of which will be coming up this way this summer, but all of it was canceled. And the story, we were right at 2018, we lose the thermal barrier, 2019, the pollock are still hanging in there, the Pacific cod are still hanging in there, the water's very warm. 2020, we don't have anything. But rurally, one small survey for the Alaska, but one giant survey for marine research during a pandemic. So with that, we've got Jen Bell, and she's going to talk about the results from the 2020 Norton Sound king crab survey. Really, one of the ones I always look forward to, but even more so this year because thanks to rural Alaska, it was in the position to move forward. Go get them, Jen.
Great, thanks, Gay. Gosh, I hope my presentation lives up to it. That's the only thing happening in 2020. Well, as Gay said, I'm Jen Bell, and I work for the Alaska Department of Fish and Game as a research fishery biologist. And we did conduct our annual red king crab bottom trawl survey. So I'm just going to go through the results, talk a little bit about the survey, and then hopefully take some questions that I can answer. I apologize. My internet got all messed up, so I apologize for not being on having a face to look at. If you care, that's my back in the raincoat there on the deck. Okay, I can't do anything with my. Okay, there we go. So this talk, I'm gonna talk. I'm gonna give a brief history of the trawl survey. We're gonna give you the tools of the trade, what we use to collect the critters and environmental information that we collect. Then give you a very brief overview on how we get the numbers. There won't be any quiz on it, so there's a little bit of math in there, but it's okay. It's too sunny to learn too much math or hear about it. And then we'll jump right into the 2020 results, focusing on a couple species of interest and the environmental data. And then I'll try and wrap it up with putting 2020 into the big picture of all the rest of the trawl surveys. First off, the Pandalus, which is the boat that conducts the trawl survey, is based out of Homer. And it's in a different region than we are. And it was also going through maintenance last summer. And so I wanted to give a shout out to the people that really control the Pandalus and the movements that it makes to allow them even to come up here into Norton Sound while everything was going on. Dave Anderson, the vessel manager out of Cordova, and Bert Lewis is the regional supervisor down there in Anchorage. So they were instrumental in allowing the Pandalus to come up here. As I said, it was also going through maintenance. And so the crew really worked on the maintenance, trying to get the boat ready to go. And we pled and we pleaded and we begged for them to get up here. And so they actually made it a reality. The captain, unfortunately, went down with an injury while the boat was being fixed. So we even had to find a replacement captain. So on top of everything else that was going on, we also had a replacement captain. His name was Lynn Potter. He came up probably with 2 or 3 weeks notice. So it was fantastic that he jumped in at the last minute. Dave Knight, who's the engineer on the boat, irreplaceable, probably wouldn't have been able to do the survey if he wasn't on it. And then we had a new boat officer, Katie Connor, who was more than willing to jump in and do whatever she needed to do. So these guys were just really instrumental in making sure that this survey went down, even though it was a crazy time of year. So a shout out to those guys. So to start with, we'll just give you a brief overview of the history of the trawl survey. Starting on this slide, these two pictures, the top picture is the back deck of the Pandalus, which is the boat that currently does the survey and has been doing it since 2008. And the bottom picture is on the Peggy Joe, the boat that was doing it prior to the Pandalus. It was quite a bit bigger, but it's worked out really well on the Pandalus. So the survey's actually gone back since the late 70s, when NOAA, who conducts a Southern Bering Sea survey, every 3 years would bump up and do the northern part of that survey. So they'd go probably to about Nunivak Island, and then every 3rd year they'd come up and they'd do Norton Sound and around St. Lawrence. That survey ran every 3 years till about 1991, and then the funding ran out. People were scrambling, and finally ADF&G came up with the possibility, with funding from NOAA as well as other sources, to start operating a triennial trawl survey, and that started in 1996. When it started, probably around 2000, it went to a tier system, which you can see in this map, which is all the stations in the blocked up area, right? And within the lines are the stations that are typically trawled. And they established this tier system where the core stations would always be done. And then depending on how much money and funding they had, they would go to these outlying tier 1, 2, and 3 stations. And if you didn't have enough money or funding, then those fell into a lower priority. Another shout out to NSCDC, who funded portions of the trawl survey, was very instrumental a lot of times in helping us complete the entire survey, as well as in several years expanded the coverage of the survey. So we went beyond this blocked out area. So they've been instrumental in making sure the survey continues as well. Starting in 2018, we decided that we were going to go from triennial to annual. So from 2018 on, it's been annual. So we've had 4 years of annual surveys, including 2017. Once we decided that we were going to go with annual surveys, we exchanged the tier system in favor of just having a set number of stations that we were going to try to achieve every year. We decided on these 60 stations, which you can tell the grid does not, or the encompassed area is not much different than the previous slide. So obviously the 60 stations were informed by the stations that were most commonly trawled in prior years, but also resulted in higher catches or more efficient. The one station that I can think of is out here on the edge, 135, was trawled in earlier years, but it's a difficult station to reach. So for efficiency, we lopped that one off. So now we have 60 stations that all have the same priority. We try to get them done each year. Doesn't mean we're always successful at it, but that's our goal, is to get these 60 stations. In 2020, we actually did complete all 60 stations, but we did start a little bit later. We started about maybe 10, 12 days later than we would normally do it. Our survey went from July 31st to August 14th, and typically we would go from July 20th to the end of July 31st. We had one station where our trawl door came detached from the cable that holds it, and what we did complete that station, we couldn't actually sample or do any kind of biological work up on that station because we couldn't bring the net in correctly. But we're still counting it as a complete station because we got it. Excuse me. So now I'll move on to tools of the trade. What do we use to collect our data? The big thing, obviously, is our 400 Eastern Otter Troll. It's our bottom trawl net. It's called an Otter Troll because it has doors, basically, that once the net is on the bottom, the doors are deployed. The doors catch in the water and they keep the mouth of the net open and the net wide. It used to be done with, say, 2 different boats, right? A boat would hold each side and hold the net open. So these doors, or otter boards, are keeping that net open. You can see them in the top picture here. The white thing on the right side of the top picture, that's the door. They weigh probably 500 or 600 pounds each. And the net, this picture is reeling in, but when the net is deployed, they're the last things off the boat. So going through these pictures, you can see the buoys in the water in the top picture. That's the head rope. And then you can see this being reeled in. The buoys from the head rope are on the reel there on the back of the boat. And then if you look in the water, you can see like a smudge of orange, and that's the cod end, and that's where all of the catch is going to. And that's ultimately what we're going to be dealing with. And then the lower picture is just it's right before the cod end. It's just smaller mesh, and you can see the organic material, sea stars and shells and crabs usually get caught in that mesh, and we have to actually shake the net down to be able to catch everything, or to census everything that get caught in the net. Excuse me. So that's how we collect all of our critters. These environmental data is collected a couple different ways. The first one is a conductivity, temperature, and depth profiler that also has a dissolved oxygen sensor on it, or meter on it. And that's this picture over on the left-hand side. It stands about 3.5 feet high, and it's lowered over the side of the boat at each station. So before we deploy the net, we find the center point on our station, stop the boat, let everything settle, deploy this CTD. And what it does is it just profiles the water column. So it just goes down. It's a set drop rate, and then a set retrieve rate. And it just goes down, hits the bottom, and comes back up. And it's controlled by a hoist on the boat. It's not anything that we do by hand. And it takes, this is a graphic that comes off of the CTD, the software. This is what they give you, is this graph, which looks really hodgepodge. But if you just take a second, you see that it gives you from the surface at 0 to a little bit more than 20 meters on the left-hand side, basically your y-axis. And then the x-axes are all colored according to what they're measuring. And then the colors of the axes match the colors of the, within the graph, the lines. So we have across the top salinity, which is blue. The bottom one is temperature, which is green. And then we have oxygen, which is a maroony red type of color. So if we look, just for example, if we look at the green line, which is the temperature, that's the first axis on the bottom, you can see that this green line starts a little bit above 13, right? So your axis is actually down. It's not that 30, but if you wanted to look there, it'd be the 30 on the salinity axis. And it goes down, you follow it, and the temperature actually gets to a little bit below 4 degrees. And then the other line is when it comes back to the surface. The surface business right there, the very top, where you can see it's between 0 and 2 meters, that's because when we put the piece of equipment over the edge of the boat, it has to sit for a couple minutes while it calibrates. So it's just getting kind of sloshed around. So that's why that looks nonsensical. But ultimately what this is it gives you a profile of the water column, and you can see that there's a thermocline right there, right? We're at 13 degrees, then we're at 4 degrees. So we see this decrease in temperature, but it's just point estimates. It's not monitoring for long periods of time. So it's just an up and down. So it's giving you the conditions in the moment, not at any other time. And the way I use this is I'll go to the very deepest in our readout. I'll go to the very deepest point, and I'll take the temperature and the salinity and the dissolved oxygen, because we really care about the bottom conditions. And I'll take those point estimates and utilize those. What's kind of exciting is in 2021, we're going to add a pH meter to be able to start looking at ocean acidity. And that's going to be purchased with funds from NSCDC's outside entity funding that is supporting buying a bunch of different sensors. So that's kind of exciting. Slightly less scientific looking, but just as powerful, is our humble Hobo Logger. This collects just temperature. It's really stout. It really tolerates just about any conditions you can put it in. This is deployed along the head rope of the trawl. We just wrap it in some webbing and then use a, what do you call that? One of the crab hooks that, whatever, the hook that you use in the crab pots. We just wrap it around the head rope, and then it stays on the trawl survey all day long. And I've included a graph that is basically the readout of one of these hobo loggers with temperature on the y-axis and time of day on the x-axis. And you can see anywhere that it dips, that means that we're doing a trawl at that time. So it's taking a temperature every 3 minutes all day long. And so we see each time it's dipping, then we know we're doing a trawl survey. What I do is once it hits the bottom, I take the average of all the temperatures along the bottom to get an average bottom temperature for each trawl survey. So this actually has a lot more data in it because it could have 11, 12, 13 data points in our average bottom temperature versus the CTD, which just has the 1 point at depth. Everything that I talk about temperature wise is using these hobo loggers or the equivalent, previous versions of hobo loggers, so we can compare through the years. Finally, excuse me, this was new in 2020 because we didn't have enough stuff to worry about. We thought we'd throw something completely different into the works. Net mensuration gear, which is just a fancy term for net measuring gear. And basically what this is these are acoustic sensors that you deploy on different aspects of the net, and they send out signals to a towfish, hydrophone essentially, that translates the information and gives it to us in this readout. So I'll go through the bits and pieces on this slide. We ended up having warp wire length sensors, which is the warp wire is the wire that attaches the doors and the net to the boat. It's called a warp wire. And you can see it in this top picture. This is obviously chained. It's not a wire, but the wire goes back is on the boat. We had door spread sensors, how far apart the doors are from each other when the net is fully deployed, and then a bottom contact sensor. The sensors that you see circled on these doors are the warp length and the door spread sensors. The holders are welded into the doors, and then the red sensors can come in and out. And then the bottom picture is the bottom contact sensor housing and what essentially the sensors look like outside of the housings. The bottom contact sensor is attached to the foot rope of the net, and it's basically an inclinometer, and it just detects when it's off of level. So when it's off horizontal, and that would tell you either the net is off the bottom or it's digging into the bottom. All these sensors work together, as I said, and send a signal to our hydrophone, which translates into, this is a screenshot of what we see in the wheelhouse. And so this gives us a near real-time image of what the net is doing. Because this was our first year, we ran into a few issues that we didn't anticipate because we didn't really know our system, but we actually were pretty effective in using the warp wire, which is the two measurements you can see on the top image of this screenshot. It was actually really effective because the person running the hydraulics and extending those wires was new to it. And so this tool actually worked. So we were actually super excited to have this, even if all of the components didn't come together. It gave me enough confidence that with a little more training and knowledge of the system, we should be able to, in near real time, determine whether the net is fishing appropriately. And another shout out to NSCDC, who was the supporter of these sensors. And we're also going to add a few more sensors onto our net in 2021 through the NSCDC outside entity funding. So yeah, I think it'll be really exciting to be able to see what the net is doing in near real time and be able to adjust if we see anything going off course or off the rails. Okay, so we're going to talk a little bit about how we get the number that you guys see at the end of the day, or at meetings or even here. I'll present them. Just a quick overview. excuse me, only happens when I'm talking. So we've towed the net. We tow for a nautical mile that's established by the GPS. So when we put the net in the water, we're sure it's on the bottom. The clock starts, the location is noted, and we tow for 1 nautical mile. Then when we're reeling the net in, this is the picture that I had showed earlier. You can see the head ropes coming up, and the middle picture with the bird on it. Seriously, he was just as the net is being reeled in, it's just turning, and he's just walking like he's walking down the street. It was actually really funny. But you can see the bundle of sea stars that the two workers are trying to move down. So we figure those are caught in the net during this trawl. So we're trying to do the best we can to move these piles of sea stars, is essentially what they are. There's other things in there, but let's just face it, most of them are sea stars that just get tangled up in the web. And so there's usually 2 or 3 people standing at the back of the boat, just trying to shake down the sea stars into the cod end. The third picture is just a really good example of it being overwhelming. This might actually be a repair job that we're doing, which is why looks like there's so many sea stars on the deck. But that's the idea of it. It's just trying to move all of this biomass that gets caught in these webs down to the cod end. Once we've shaken it all down and the net is completely on board, we need to get a weight for the catch. And so what we do is we wrap just the cod end, which is this end at the very end. This is the orange piece that I was talking about in the earlier slide. We wrap a line around that, pick it up. There's a scale, this gray box in this picture on the left is a scale, and we pick the whole thing up with the boom on the boat, and then the scale's whipping around, the net's zinging around. We try to get a good estimate of weight. Once we have that, we empty the net, which is what's on the right-hand side of the picture. We empty the net onto the deck. And then what you don't see is we're taking another weight of that empty net. So we have a gross weight, which is everything we caught plus the net. We empty the net and then weigh the empty net, and we get a net haul weight. So it basically just how much the stuff that we caught weighs. And that can be these pictures are all lovely and make it seem like it's not the craziest thing ever. But I assure you, with just 1 or 2 feet of rollers, it's all over the place. And this example net was very tiny, but we've had to deal with larger ones that end up breaking those boards. So it doesn't look it's not always as pleasant as these pictures indicate. So once we have everything out on deck, we tend to pull out rare species, large species, things that wouldn't be easily subsampled. And I'll explain subsampling in a minute. And anything that would be commercially important. And I've included a couple examples. The top picture is an Alaska skate. And then we have a halibut in the lower left-hand corner. And then of course we pull out king crab. We pull out any one of these individuals, we pull out as many as we catch in the trawl. So we try to get all of them from the trawl. And included with these species is also any kind of large debris. Like if a huge branch comes up or a large rock comes up, we also try to include that. Again, anything that wouldn't be easily subsampled. And what we don't have any pictures of is pollock and cod, the pea cod or Pacific cod. We do take all of those out as well. It just turns out that they're not nearly as exciting, so nobody takes any pictures of them. So I couldn't find any of those. Once we have them all collected, or while we're rooting through them and trying to get them all collected, we also do collect biological information from as many things as we can. For the Alaska skates, we just collect weights. For halibut, it worked out perfectly that we had somebody the same size as the halibut, so we didn't have to measure it. We could just measure the person. We do try to capture weights. We do have a length weight conversion for halibut if we can't, if it's too large. We do try to do everything pretty quickly so that we can release these animals live back into the ocean. With the crab, what's happened, what you're not seeing in this picture is there's probably somebody that's already starting to work up the crab. So we're doing the same thing with the crab. We're trying to get them sampled as quickly as possible and collect the biological information and get them back as quickly as possible. The only thing that gets sacrificed are the pollock and the cod. Usually they wait, because there are so many of them most recently, they tend to have to wait until everything else is completed before they get measured and weighed. So once we've got all those whole haul species out of the way, I apologize for the clock if you can hear it, we take a subsample of the catch. And in the picture on the left, that's what we're doing. We fill these 3 orange baskets with what we assume is a representative sample, right? We're just going in with a shovel, taking a big old scoop and throwing it in the basket. We're trying not to have any kind of bias in our selection. And we take it from all aspects of the pile of biome, or the pile of animals, just so we can try and get a representative sample of what we've captured. Once we've taken the subsample and we've got everything weighed and we're confident that our subsamples are good, we go ahead and push the remaining organisms overboard. So as quickly as we can get all of this done is how quickly they can get back into the water. Once we have our subsamples, as I said, we weigh them, and then we all sit down and start sorting into the lowest possible taxon. And depending on who you are or who's on our boats, is whether how much resolution we get on our taxon. Some people are really good at identifying different species of shrimp. Others are just like, this is a shrimp. So we can get different categories. But we go down to the lowest level that we can reasonably identify without any microscopes or having to do any dissections or anything like that. Then once we've got them all sorted, then we count the individuals for each taxon and then weigh that group. So if we have 50 sea stars, we know we have 50 sea stars and they weigh so many grams. So once we've done all that, and that's what we do for every trawl, for all 60 trawls, that's what we do. And then I get the numbers back at the office. We've entered all the data, everything's good. But what does it mean? What do these numbers mean? Well, this whole thing is predicated on this idea of the area swept. That is the area that the trawl actually covered. And so for us, the area swept is the length of the tow, which we assume is a nautical mile, times the width of the net. And the net's 40 feet, about 40 feet wide. So we put it in nautical miles, which makes it this ridiculous decimal point. And then to make it even more ridiculous, you actually have to go out these 8 numbers, because it actually makes a really big difference if you don't go out those 8 numbers to get the ultimate number. Actually varies a whole big bunch if you don't take it out to 8th decimal point. So it's 40 feet. You can just trust me on that. Or do the math and find out that the width is actually 0.00658316 nautical miles. And that is the area swept by the trawl net. Now, what I didn't explain to you at the beginning was using these station maps is that each one of these numbers is actually a grid that represents an area that's 10 by 10 nautical miles. So the grid 153 represents 10 nautical miles, and we've towed some area swept in there, right? It's pretty standard because for our survey, we actually assume the length of the tow. We know the length of the net. So we just assume this number is pretty consistent between tows. So our area swept is just a small segment of this 100 nautical miles. We do the math on this, and that's where the red king crab comes in. For red king crab only, we actually take our trawl, and I always say we blow it up to that larger area. So, and I'm going to talk abundance, so the number of crab, it's easier. We do this, the math works the same way whether you do abundance or you do biomass. So I'll say abundance because it's easier to talk in animals, or number of animals, than it is to talk in weight. So we calculate an abundance for each station, which means we take the number of crab that we caught in the trawl net and in that trawl, and then we multiply it by the ratio of the total area to the area swept. And we get basically how many crab do we think are in that 100 nautical mile area, right? Based on the fact that we did a 1 nautical mile tow. Once we have that number of crab for each grid, we add all those stations together, and that's how we get the abundance, which we'll actually give you an abundance, our abundance estimate a little bit later on. But that's how we get our 2020 abundance estimate. Now, that includes even the zeros, even the stations where we didn't catch any crab. Now, it seems obvious zero doesn't change anything. If you're adding 0 crab to 5 crab, you still get 5 crab, regardless of whether you use 1 or 2 stations. But it makes a difference when those numbers go to the bigger the model and beyond just this abundance estimate. So it's important for everyone to realize that those zeros where there are no crabs are actually still part of the data. We don't call those stations out. For all the other species, we could do this for every species if we wanted to, but it gets a little overwhelming. And so for the other species, basically what we do is a catch per unit effort by station. And we just take the weight of the individual taxon that we've identified and sorted out to, and divide it by the area swept of the trawl net. Then we calculate that for each station, and then we calculate an annual CPUE, which is just the geometric mean of the station CPUEs. And the geometric mean is essentially the center point of the station CPUEs. And those, we do not include the zeros there because the geometric mean does not allow for zeros. So it's basically just the center point of all of the non-zero station CPUEs. We do that for all the other species, and that's how we talk about we talk about the top 40, the top 5 species. We use the annual CPUE. All right, so that was too much even math for just a little bit. It's too sunny for math, so let's jump into the result. The big one, we got red king crab. We caught about 320, well, it's not about, we caught 322 crab that we detected. There, every once in a while we'll get really, really small crab. And we had a fellow on the boat a couple of years ago, and he was really good at finding micro crab, is what I called them. They were just, I don't know, half an inch or smaller crab, and he was so good at finding them. And you can see there was a blip in our data that had all those small crab, and the rest of us are not very good at finding those micro crab. But these are the ones we could detect, ones we saw. And all of these will be in maps of where these are all the stations that we trawled. So you can see the large numbers and the dispersion of these crab. This is all the crab. This includes males and females. If we break it down into just male crab, we caught 121 sublegal crab. And sublegal is, for those who are unfamiliar, sublegal crab is a crab that's less than 105 millimeters carapace length. And we measure carapace length from the eye socket of the crab to the tail. So we measure across the body from the eye to the back, where the fishermen would typically measure from side to side. Because of the spines in the red king crab, we want to minimize the variability in the size, and the eye socket to essentially the back of the shell is very consistent. It's replicable on each crab. So when I talk about legal size that way, I'm talking about the carapace length. So we caught 121 that were sublegal, and 91 of them were new shell, which new shell indicates that they molted. With sublegals, it may be that they molt once a year, they might molt twice a year, but they had recently molted, so their shell was new. And then we caught 15 legal crab, and they were predominantly new shell as well, with 10 of them new shell. And then here is the size composition, the frequency of the male crab that we captured. Notice that the majority of them are sublegal. They're less than 105 millimeters carapace length, with the most coming between 80. The bins would be 81 to 85 would be in the 85 bins. So the size of 81 to 85 had the most crab. And then you can see I've split it up into pre-recruits, which is essentially sublegal crab. And that's 89% of the catch was pre-recruits. Recruits are those crab that just recruited into the fishery within that year. They're 105 to 114 millimeters. So they just with their year's molt, they just turned in or just became available to the fishery. And then post recruits are those crab that they're probably 2 years available to the fishery, and they're larger than 115 millimeters carapace length. And you can see we had 7.4% recruits and meager 3.7% post recruits. For females, we captured 186 females. One had a missing tail, so I couldn't identify her as mature or immature. But of those 186, 29 of them were juveniles and 156 were mature. In a female crab, you tell by the base plate, and I have a picture in, I believe, the next slide. You can tell if a female is mature by the presence of eggs. If she's got eggs, she's definitely mature. But if she doesn't have eggs, then you can tell by the plate, the tail plate that comes up and holds the eggs, how big that is. So we can tell whether the male or the female is a juvenile or a mature female. And you can see that there was a bit more dispersal with the females, but there is still that one station where we caught 102. That'll come up later in the talk and why that might be a little bit of a concern. Of the mature female, so we have this picture on the side. This is looking down. Imagine you're looking at the mouth and the eyes of a crab. So this is looking at, looking down on top of that, and you pulled the base plate, and those purple things in there, those are the eggs. Those are the female eggs for anyone who's not familiar. And so out of the mature females that we captured, there was 146 that had eggs present. And then there was 7 that were barren with clean pleopods and 3 that were barren with matted pleopods. The difference between the pleopod, clean and matted, is clean indicates that she hasn't mated in this season. And matted pleopods suggest that she had eggs and she just released them. In order for a female to successfully mate, she has to molt. And so females can molt and not mate, which would result in clean pleopods. But if she had matted pleopods, that would suggest that she had released her eggs and she wasn't even ready to molt again, or to mate again, because she hadn't molted. So very low percentage of the barren females, which is really good. And then this is the whole thing, the whole reason why everyone's interested in the trawl survey most years is to get our abundance estimate of legal males. This sets is provided to the federal government, who oversights red king crab fisheries in Alaska, and then trickles down and helps us set our guideline harvest level. And so this is a history. This is a historic table of all of the abundance estimates. This includes all the trawls back to 1976. Also includes some pot surveys done in the mid 80s that were, or the early 80s, excuse me, that were used at the time to help determine abundance. So those are also included in here. And the very bottom line that I've highlighted in red is our trawl survey. You'll scroll over and scroll down and note that legal males, we have about 228,000. That is our abundance estimate. Again, with this, adding all of the stations up that we caught crab in. It is by far the lowest number of legal males that we have seen in the history of the trawl survey. Encouraging is if you go two rows over, and I apologize for not highlighting this better, is pre-recruit 2 males. And you see that there's about 4 times as many pre-recruit 2 males. And so that kind of speaks to what, fingers crossed, will eventually grow into legal size and fishery size crab and the size that subsistence users want to harvest. So there is hope that those crab are going to get bigger. But yeah, right now we're at a historic low legal size. This information is used in conjunction with other crab data, including the commercial fishery catch, and it is used to inform a model that's used to set all of these guideline harvest levels. So this is not the only piece of data, and this 228,000 is just for our trawl survey area. There's a lot of other work and business that goes into expanding this number to cover the Norton Sound area, which is where the commercial fishery happens. It's a big deal. I don't want to spin off into the model because I probably will be wrong. Okay, so beyond red king crab, the other species that I know everybody cares about are these pollock and cod. So in 2020 for Pacific cod, we caught 133 of them. They tend to hang out in the western stations. This is because the water's a little deeper, it's a little colder. I will say that in 2020, it did seem like they came in a little bit, right? If we draw a line from Cape Nome, which is the point between Nome and Solomon on the map, if you drew that line, the fact that we're catching cod in there is, usually they're on the outside stations, the last two rows of our survey. So that was kind of interesting. They were just a touch smaller this year than they were last year. And the chart off to the side, on the right-hand side, is the history of the catches of Pacific cod and walleye pollock, you'll see on the next slide. So we caught 93 in 2019. So we caught quite a few more, but we're still within what we've been catching since 2017, right? We had traditionally caught pea cod in the trawl survey. It just seemed to be that in 2017, they just kind of exploded and we were like, wow, holy cow, we're catching a lot of cod. What we don't know, this shouldn't be taken as any kind of indication for abundance or biomass, because our trawl survey is not intended to catch cod. And so we know likely there's more cod out there because our numbers have increased, but even that's it's hard to even say that definitively, because it could be that there's no more out there, they're just in a different spot. So it's really, I urge a lot of caution in using this trawl survey to say anything too far flung about Pacific cod and walleye pollock, because we're not really set up to catch them. That's not the point of this survey. But since we have a history of catching them, it's appropriate to report it. We did do some belly composition, or we cut open bellies for NOAA in a cooperative project with NOAA, and we identified as low as we could to taxon of what was in the cod's stomachs. And for the most part, it was pricklebacks, lumpennis, if you're familiar with the scientific name, and helmet crab. They really enjoyed the helmet crab and little opilio crab. And up here, the opilio crab are, they're maybe 2 inches long. That's a big one. You know, and I'm like legs included, they might be 3 inches. So they're really tiny up here. So you really have to you have to really go after them if you're going to make your living off of these tiny opilios. But we have found soft red king crab and pea cod stomachs, but it's not prevalent. It isn't it's not like we open every stomach and find a king crab and other species. We find so many other species, and then every once in a while we'll find a soft-shelled king crab. And it usually coincides where, if in the trawl survey, because we also look at shell condition for king crab, we would find an increased number of soft-shell crab in the survey. So it may be something that it's just like, okay, they're targeting this area. But not every cod comes up with a king crab. I know that's a concern for some people, that they're eating the king crab. For pollock, they are consistently higher numbers than the pea cod, and we caught 569. That's down slightly from last year, but still, again, within the realm of of what we've been catching since 2017. This looks like one other thought about the trawl is we didn't trawl before 2017. So it was 2014, small numbers of these large fish. And then we started in 2017. We don't know what 2015 and 16 did. And there was no NOAA survey either. So there wasn't a whole lot to help us detect. We just started trawling in 2017 and detecting them. So they could have been here in 15 and 16. And we just would not have known. It doesn't seem like it based on everything we understand, but there's a possibility there. But anyway, back to pollock in 2020. These guys, they have typically moved further east than the cod. We have caught them in the middle stations. And so the numbers are probably a little bit shocking to see that many heading that far east, but we have caught them over there. So it's not unheard of to actually have these cod or these pollock moving east. They were just slightly larger than last year. But yeah, and again, the same cautions go with pollock as they do cod. Our trawl survey is not designed to capture these to create a census. So we don't know what we're missing, if we're catching everything or things are swimming out. We have no idea. So this is just an overview. This is what we catch. Being able to say a whole lot about it is not likely. All right, so the final species of interest I have is I call it species of aggravation, because I'm sure if anyone is out there fishing for just about anything that requires a pot, you are familiar with the purple orange sea star. It is endemic to Norton Sound, and this poor soul got the job of counting the sea stars, and he counted about 13,000 of them on the trawl survey. And understand that these are subsampled, right? So these are the 3 baskets of sea stars, the 3 baskets from our subsampling at the beginning, right? And out of all of those subsampled baskets, there was almost 20,000 sea stars. So this poor guy had to count the 13. I don't know who counted the other 6, because I'm pretty sure I didn't count any sea stars, but sea stars are doing just fine if anyone cares and is concerned for them. Here's a top 20 by annual CPUE, which is what I explained how we do for most species. We just deal with annual CPUE. And I thought I'd point out a few of the highlights. Now you can see the number 1 is that purple orange sea star, and it's an order of magnitude larger than the next most abundant organism, which was saffron cod, which is kind of exciting because people utilize that here. And then we've got pollock coming in at the 3rd spot, and then cod, Pacific cod, fell out of the top 5. It had been in the top 5 for a couple of years, had fallen out of the top 5 to number 6. And then for those who are interested, we got Pacific halibut, made it to number 15 this year, and even red king crab crept in at number 19. So again, it's just interesting that we have this purple orange sea star right at 23,000, and then red king crab is 78. So we're even now almost doubling the order of magnitude for those sea stars. They're just amazing to me. I don't really understand how so many sea stars can exist in one spot, but they're doing something right. So anyway, most of the things on this list are invertebrates you might expect. The fish, obviously, the fish are much larger, so it doesn't take nearly as many fish to get to a higher CPUE. All right. So let's look at a little bit at the environmental conditions that everything faced in 2020. So this is a grid again, or the station map of bottom temperatures, and recall that these are the Hobo Logger. So this is the average temperature of the trawl as it's moving along the bottom, as it's going along that nautical mile. And I averaged the temperatures along that nautical mile. And you can see that we have colder temperatures in the more western stations. It warms up there in the middle and then actually cools off as we head further east towards Unalakleet. and it's interesting, it's not unexpected to have the really cold temperatures off to the west there. That's pretty typical. It's bigger water, it's deeper water. But what I find interesting is that the east, which is typically the last couple of years been warm, is actually, those eastern stations are pretty close to those western stations. And I'll have a map just a little bit later, or a graphic that actually indicates that's a little bit different than what we've been seeing. And then this middle business where you're seeing 10s and 11s, I think that might also be impacted by the Yukon River coming in. And so there's the very tip of the Yukon Delta you can see in the bottom of this map. And so Norton Sound is very, very heavily influenced by the Yukon River water. And I'm guessing that those warmer temperatures can be attributed to that. For salinity, and these are all, remember, we're thinking bottom because we're focused on crabs. So I'm just giving you the bottom things. We do collect surface temperatures and surface salinities off of the CTD, but I won't go into them simply because we're bottom oriented. So the salinities from the CTD, remember, and this is just a point estimate, are again similar to what the water is that you, or what the temperatures were that you might expect, is that you move out of Norton Sound, the salinities, it tends to get more salty. Average salinities, I don't know, 32, 33 is ocean water. And then we can get down to, in Norton Sound, to 24, 25. Salinity is given as practical salinity units, which is for all intents and purposes parts per thousand. So you can read this 31.7 parts per thousand, or PSUs, for this northwestmost site. So it's definitely saltier as you're heading out of Norton Sound. And again, we have this middle section where the salinities are going down, perchance because of the Yukon Delta. And then we see them kind of come back up and hover a little bit lower than the west, but still pretty saline. And one of the things I'm thinking is we just didn't get a lot of we didn't have a lot of snow melt last year. And so maybe that's one of the reasons why the salinities in Eastern Norton Sound are actually higher, less fresh than they have been in years past. Again, I'll show you a graph a little bit later, explaining or highlighting that a little bit more. All right, so to wrap everything up, I told you I would try and put 2020 into the big picture. So one of the things that we were not expecting in 2020 was the lack of growth in sublegal males. We didn't see the expected growth of the cohort from 2019 to 2020 in our catch. So this graph shows the length composition, density, essentially length composition of male king crab in the annual survey. So 2017, 18, 19, and 20. In 2018, we noticed, I mean, there was a huge number of male crab, as you can see in this graphic, right? We've got this peak between 30 and 50. And we were super excited because we hadn't really caught anything like that in 2018. But we were even more excited because we caught those crab a year later and bigger, larger, in 2019, which means they had grown, and this is great. This is a cohort. This is fantastic data. Oh my God, we're brilliant for starting an annual survey, right? We're super excited. We're patting ourselves on the back. And then we get to 2020. And you can see that we did catch some of the cohort, but it didn't grow enough for it to actually have moved through and do exactly, you know, the really nice science we have from 2018 to 2019. And we fell on our heads a little bit in 2020. The question though is why? And it's not a question we can really answer because we don't know what we didn't catch, right? So it could be that there's something wrong. There was a mortality event between 2019 and 2020 that some of the crab that wanted to grow, didn't, or they died. That could happen. We just didn't catch them, right? Think about how much we're actually trawling compared to the size of even the station grid, never mind of Norton Sound, right? So they just may not have been in the path of the trawl, but we don't know, right? Because we don't have any ability to, at this point, to understand what we don't catch. I have molting up here because maybe molting is an issue, and I'll talk about that in the very next slide. But there could be other ideas that we just don't know. It's really tricky to say, okay, this is the end all be all data, because there's so much uncertainty in just doing, even though we're super excited we got the trawl, it's only one tool, and it serves a actually very small section of the larger area. So we don't necessarily understand why we didn't get the growth that we might have been expecting. I had mentioned shell condition or molting. So a crab, in order for a crab to grow, it has to molt. And if it doesn't molt, that's usually indicated by a shell that looks like it's been used for a year, right? It's got growth on it. The spines tend to be a little bit worn. The walking feet, the little dactyl tips, they tend to be worn. It's like it's been worn for more than a year, right? So we identify crab by whether they're new shell, whether they're old shell, very old shell, right? That's like, now we got barnacles on it. That guy hasn't molted in a long time. And in 2020, we saw an increased proportion of sublegal crabs that had old shells. So essentially, those crab we think did not molt. What we're unsure of, or what I'm unsure of, is whether that amounts to enough of a percentage that it would actually stop the growth, right? From 19 to 20, that percentage, which is a little over 20%, would that be enough to say, okay, well, if we're assuming that 95% of those crab molt, but only 80% of those crab molted, would we see these numbers? I don't know how we can resolve that. So this is one area where we may have some information, but it would be really tricky to resolve whether molting actually impacted the outcome. What I'd like to do, and you can see that these molt level, or these molting proportions, even 2019 excuse me, 2020 was a higher number, but there's other years. This is, I'm sorry, the left-hand graph is the shell condition of the males, the sublegal males in the historic trawl surveys from 1996 to 2020. So you can see that really dark gray bar is actually, there's other years where it maybe is not as high. I think 2002 is just decimal points higher, but it's not really beyond what we have seen in the past. And so that's why I say we're not really certain that that is indicative of what, or was the reason why we saw what we saw in the 2020 catch. For future work, what I'd like to do is drill down into these old shell crabs and find out what their size composition is, right? Sublegal crabs span from we call everything that's less than 105 millimeters, right? Something that's not legal is sublegal. So everything that's not legal is sublegal, but what is the makeup of these old shell crab? Are they the same within each one of these years? Do we have larger sublegal crab that are old shell or smaller? I don't know necessarily the size composition of these crab yet. So that's one of the things I'd like to drill down in a little bit. And then another thought, which will explain itself in the next slide a little bit more, is if there's a linkage between molding and mating. And what's been really interesting these last bunch of years is the number of females that we've captured in these trawl surveys. It's been staggering, and there isn't very many other surveys that even come close to the number of females we've captured. But they're in the cohort. They're the same age class as the males that we saw in 2018, 19, and 20. So they're in the same age, same cohort. And so what we don't understand is how that may be impacting the males and what they're doing. What we do know is that in 2019, so now we're looking at females, this graph is clutch fullness. So how many eggs a female has. And this is again through the history of the trawl survey from 1996, or the ADF&G trawl survey, 1996 to 2020. And then the percentage of the clutch or the percent that she has, how full her clutch is, or whether she's barren with clean pleopods, right? That means she actually did not mate in that year, or she's barren with matted pleopods, which means some earlier months before the trawl survey, she had just released her eggs and hasn't had the opportunity to molt and mate again. Well, in 2019, in our trawl survey, we saw a high incidence of barren females. Close to 50% of all the females that we captured that were mature were barren. And so we were like, yikes, right? Maybe this is concerning, right? You can see there's a couple other years, it's indicated by the red bar. You can see there's a couple other years where we did have high numbers of barren females. So we weren't like, oh my God, we've never seen this before, but we still a level of concern. In 2020, it resolved itself. And so you can see that there's just a small, almost historically low number of barren females in 2020. Why might this be? Particularly if we're not making any large crab, right? This cohort we're not making any legal crabs at this point. It's just tracking the smaller crab through time. So this is where it all kind of comes together. Is my idea, my theory is that this cohort, which this is the similar graph that I showed for males, but this has got males and females. So males are the lighter gray, females are the darker gray, almost blue. This is a size composition through all the surveys. We've got 2004 in this graph. We have 2017, 18 is when we picked them up, 19 and 20. So if you look at 2018, we have a lot of overlap between the male and female size comp. In 2009, and neither one of them are mature. So in 2018, crab were not, this cohort was not they were not mature. They were still all juveniles. In 2019, we have female crabs becoming mature, but male crabs are the same size. The only way male crab can mate is if they are larger than the females, because they have to grasp them. So within this cohort, we have females that are mature, but males that are not functionally mature. They are not large enough to mate with these females. In 2020, you start to see separation. The females are mature, and once they mature, they also slow down in their growth. And so once they slow down, the males continue to grow at their normal increment, and they are now surpassing the females. So there's potential that this cohort now is sustaining itself. What we're looking at now is the idea that this functional maturity is smaller than we had originally thought, and that once they get to be like 80 and 85, the male crab are actually capable of mating. Currently, we think it's about 94 millimeters, but it's possible that it could be smaller than that. And we actually are doing live tank studies to try and figure that out. So that's what the bottom sentence is about: ongoing work to examine the functional maturity. So having said all this, and this harkens back to what I was talking about with the females, that 102 at that one station, all of this is kind of thrown into a tailspin because we have caught an unprecedented number of crab at so few stations. So if you look at these maps, are just the same station maps from each successive year. Males are on top, females on the bottom. If you look at the number of males or females that we've captured, they generally come from four or three stations. And in 2020, the males seem to be more evenly dispersed per usual, where the females, as I pointed out, that 102, right? So we have captured so many crab in such a small area that it's kind of throwing us off. It ends up increasing our uncertainty in our abundance estimates, because the part of the idea, right, is if you if you have around you, right, if it tapers off, right, if you start with a whole bunch and it just tapers off, you've got this kind of pile of crab that just kind of easing into all these other areas. Well, what basically this is saying is you have crab here and you don't have any crab here. So the error between those two estimates is gigantic, and it's kind of throwing off our estimations. And so there's a lot of uncertainty on our estimations because this is something that we haven't seen, this, you know, high incidence of crabs at 2 stations. It also happened in 2014. There was 1 station that captured everything. And yeah, it throws off a lot of the calculations. All right, real quick, we'll wrap up the environmental data. What I did was I took the bottom temperatures from 2002 to 2014 at any station that had temp data. So not all stations had temp data. And I took the average of that temp data at each station. And then I compared the last 4 years, 2017, 18, 19, and 20, to that historical average. And this graph is the deviation from that average. So think of the average as being on that 0 line. And then it's by station. It goes from the northwestmost station to the southeastmost station. So we're moving north, south, west, east across the grid. And that's how the stations are laid out on the bottom. You can see in 2017, this is no surprise to anyone, that we just saw this crazy warming trend. And those hashed bars are actually track really well with that. We did see this increased warming across all stations. And then through 18 and 19, we saw the pattern continue, but it altered a little bit in that those westernmost stations actually stayed cool compared to historical averages. But as you moved into Norton Sound, you actually got warm again, right? And we all know Norton Sound is pretty shallow, so it's not beyond that. Other factors are also driving the temperature of Norton Sound. Just because it's so shallow, it could be, you know, this amount of sun. So we saw that pattern through 18 and 19, but then 2020 happened, and excuse me, these are the darkest bars on this graph, and you can see that 20 was consistent with what 18 and 19 were doing in the eastern or the western stations, but then it actually stayed cooler into the eastern stations as well. We all remember last year, or maybe we don't, maybe I just think in terms of weather, it was cold. The ice stayed around for quite a while. I'm not going to pretend I'm an oceanographer, and so I'm not going to say too much about what this may or may not mean from, you know, the environment around me. I just know that when I'm walking my dogs, it was cold last year. So I'm thinking that maybe that had something to do with how much bottom water, how cold the bottom water was. That we had this kind of a similar pattern with salinity. Now, for salinity, we've only had the CTD to obtain salinity since 2014. So the data set is way shorter. And I took the average of 2014 and then 17, 18, and 19. And that's on this graph, which gives us salinity on the y-axis, again, along with station on the x-axis. And the average salinity for those 4 years is the triangles. The stations are again set up the same way, north to south, east, west to east. And you can see 20, which is the circles. Overall, we tend to be more saline throughout Norton Sound, right? As we're moving wet, we're really salty at the mouth of Norton Sound, which kind of makes a lot of sense. It's, you know, straight up ocean water. And then as we move in, you might expect it to get a little fresher, and it does get fresher, but it's amazing between the average and then 2020. And one of the things I believe is, like, not only was it cold last year, we didn't have a lot of snow. And in 2018 and 19, we had a lot of snow, right? And rivers were high for a really long time. And I'm wondering if that was helping drive the salinities in the bottom, you know, basically the water was mixing in and the salinities at the bottom were actually freshening up because we had so much snow melt. It'll be interesting to see what this summer does, where we didn't have a lot of snow through the winter, but man, for the last month and a half, it's just been snow upon snow. So it'll be interesting to see if this pattern persists this summer, or we go back to being a bit fresher in the Eastern Norton Sound. So to sum it all up, I think it's important that we continue to conduct our annual trawl survey. This is something we're going to push for. I'm going to push for. I just think it would be nice to believe we're brilliant. As I said, brilliant about the time we picked to start doing an annual survey, that we've suddenly captured this cohort of crab. We suddenly captured warming temperatures and cod. It was just blind luck. There was nothing more than that. But it showed that maybe we were missing some bits and pieces with the triennial survey. And so I think it's important, because we could be tracking cohorts of crab from this immaturity when they're able to be captured by the trawl through to legal size and beyond. Same with the tracking the temperature and the salinity. We just get a much more refined picture of that if we can do that every year, rather than having these data gaps. And we can also look for changes in species composition or biomass or CPUE over time at just a finer resolution. The work has been done to see if there was a change over time. I believe from 2005 and earlier, they were looking to see if there was any species changes, and it hasn't been replicated, but it's something we can certainly look into in the future, particularly as climate change becomes more obvious or apparent, or continues doing whatever it's doing. Current and future work, I just touched on these a little bit. I would, really want to look at the functional maturity, the size of the male crab that are able to mate, and see if that has anything to do with the patterns that we saw for the barren versus not barren of females. That's a live tank study. And so with that, because there's females down there, we're also hoping to get some information about the fecundity and egg development. We look at the eggs and we say, yeah, it's about half full. But if we could get some numbers on the amount of eggs, how far along are they when we see them in the trawl survey, that kind of business, I think it would be exciting to know more about the females. And one of the things I didn't really touch on at all is large males, which we struggle to have large males in this fishery. If we get something that's super big, usually it's like, wow, it's a photo op. But it's weird, because our model predicts we should have a lot more large males. And this isn't a problem within the last 5 years. This is an ongoing, forever problem that we just can't seem to find these large males. So we're doing a little bit of work for that with satellite tags to see if we can pinpoint where large males are within Norton Sound or without Norton Sound. So with that, I'd really like to thank the other people that are working really hard to help us advance our understanding of Norton Sound red king crab. NSCDC has been instrumental in keeping the trawl survey going. They are supportive of us purchasing gear to help make our trawl survey more effective. They provide personnel in a pinch. They're just fantastic and really supportive of the trawl survey. So we appreciate that. And NOAA, who are the people right now that are doing the live tank studies. And hopefully that will continue for the next couple of years so we can iron out some of those questions. With that, I apologize if this is long-winded, and oh my God, it was really long-winded. Sorry.
Not long-winded at all. It was very interesting. So
oh my God, that was like a half an hour longer than I ever practiced it. I apologize.
No, don't apologize. Well, we'll see what the audience has to say. So are you're done now for questions?
Yes, I'm sorry. I didn't mean to have that reaction.
No, it's all good. So for the audience, so one thing is, thank you for sticking through. Like me, it was interesting right up to the end. So no, don't feel bad about going over. One thing we have in Nome is time, so that's good. And Wes Jones has a couple of comments. But Wes, I'll get to you in a second. And for everyone else, it's not easy being the Strait Science speaker. So please show a little love in the chat box. And to do that, if you're not familiar with chat, you look down on the toolbar on the bottom of the page, and there is like a little bubble, and it says chat. You click on that, and you'll get a text. Either that, or you can unmute, which is the microphone down on the lower left on the toolbar, and if it has a red slash through it, you're muted. Wes, we'll get to you, but there's actually a caller on the line, and it is really tough to be a caller on a Zoom call, right? Because you're not seen and whatnot. So if the caller has a question, I'm going to hand it to the caller. Do you have any questions? No questions from the caller. If the caller has any questions, barge right in, because around here, it's difficult sometimes to maintain the call, especially if you're calling from one of the more remote communities. So we want to give priority to callers. Hearing nothing, go ahead, Wes.
Okay, yeah. Jen, I want to thank you very much. Thanks for giving the shout out to NSCDC. We're really happy to support the work and especially the yearly trawl survey and anything we can do. I did have a couple comments. One on your eastern Norton Sound, the higher salinity and the cooler temperatures last year. A couple notes that kind of follow what you're saying with lower snowfall. Also here, specifically here in Unalakleet, we did not see the big Yukon plume come in with last year, and then we didn't have as many west wind storms through the summer that a lot of years we see. So those could have affected a few of the things there, specifically that fresh water from Yukon. The other comment is you were noting about that you didn't see that like the pre-recruit ones mature as much, and kind of puzzled you that you didn't see that growth, but then also saw some higher old shells. I don't have a citation. I was told about some research in Canada on snow crab that when their large male population decreased, they saw that the reproduction, the smaller males were doing they believe were doing the insemination. They also then correlated that to a higher mortality of those males, and what I was told the thought is that those males were expending the energy in mating, and then because they were a smaller size, they actually became more susceptible to predation versus when older males put all that energy into mating, but they're larger, and so they were just by size being able to fend off predation better then. So just a thought that, and I don't know where that research has, but it was talked about at a Opilio snow crab talk on the Bering Sea sometime in February of this year, I want to say. So thank you. And thanks very much, Jen, for the presentation. That was really good. It may have been long, but it was very thorough and very helpful to understand a number of things. So thank you.
You're welcome, and thanks for the info. Yeah, I'll see if I can track down that snow crab work.
Yeah.
Just a curiosity on the screen. Does anyone else see on the screen in front of them the blue streaky marks that were added? Or does no one just see Jen's normal slide?
I see it.
You see it? So that was interesting. So Anne's iPod, it was lighting up on my screen as those blue lines are being drawn, and I don't know what was going on. I've never seen that before on. But anyway, know that I was just curious if anyone else is seeing it. Not a big deal, but I think if somebody was drawing or something, it somehow transferred onto the presentation mode, and I'm still scratching my head on that. But anyway, any question, Jen? You're getting lots of good comments. And Wes, there was a comment or like a question about opelios, and you did mention that in your response. So I hope that took care of that, Kevin. You had that was caught that. Any other questions for Jen from the audience or the caller? I know I've got some questions. So, Jen, because I'm a little bit more western Norton Sound, western into the Strait region typically, Hanasaki crab are always a big deal when people get Hanasakis. And in the Strait, it seems this spring, whether or not maybe because of less shore ice, people had to crab closer to the beach, but it seems like quite a bit of Hanasaki were caught. Do you catch Hanasaki in your survey?
We do not. And everything that I've heard is that they tend to be closer to shore anyway. A couple years ago, there was a pot survey, and I'm not trying to step on anyone's explanation toes here. Wes, you may have more information on it. We, NSCDC was attempting to do a pot survey of Hanasaki crab, and they went over there, they were on the Pandalus, and it turned into a blue king crab pot survey because we were told that we were way too far offshore to catch Hanasaki crab. Now the timing is not the same at all, right? This was in the summertime versus now, but it's my understanding that the Hanasakis are closer to shore. The blue king crab are in rocky areas further offshore, and then red king crab are in predominantly non-rocky areas. So we don't catch, we may have caught one in our survey over the years, but it's not dominant at all. And I think we've caught a couple blue crab as well.
That's interesting. Thanks. I know that the NOAA Fisheries Race Division's bottom trawl survey is coming back this summer, if all goes well. And so we will have Lyle Britt and his crew talking about that. And I know that they've always been sort of confounded as well by people keep talking about Hanasaki on the islands, but he can't seem to get those boats in close enough to really get an idea of what's going on there. So
yeah, I definitely think they're near shore pot survey type of crab.
And Lyle signed up for a Strait Science in November, so we'll get the full skinny on the bottom trawl survey then. My second question is, and then I'll let the audience take over. My second question is, will we have a trawl survey in 21?
Yes, it is our hope to continue the trawl survey into the future. And every time I say that, something happens to make it just a little less certain, but it is our hope. We're trying to find different funding sources. If anything, what started as maybe a lark and, oh, I wonder if we could, has actually bared out that maybe we should. And so everybody's working really hard to get this survey done. And so we've got commitments from the Pandalus to be available. Yeah, we're trying really hard to make this work so that not even next year, but at least several years into the future, we can have this.
I think it's awesome. So thanks so much. All right, I'm opening it up to everybody on the other side of the house. Anybody have any other questions for Jen? All right. With that, I'll say thanks again, Jen. It was awesome, and I'll send you all the. One thing's really nice is the audience in Nome is really
Starving.
They're honest with their thoughts, and people do chime in, and it's really nice to get kudos when you see kudos come in. I think people mean it. So for Strait Science, so thank you, Jen. For Strait Science, the next Strait Science is going to be next Thursday on the 29th. The next two Strait Sciences, the 29th, next Thursday, and then the 6th of May, are both going to be birds. So for the bird people, that there's going to be Hector Douglas is going to be talking about the auklets at Diomede and the 2015-16 heat wave and how that seemed to affect the birds, or whether or not it did, at Diomede. specifically crested and least auklets. And then we're getting a return of Dan Rizzolo with the U.S. Fish and Wildlife Service, and he's going to be talking about his loon research up by, I think it's Kotzebue or up Noatak, something like that. So we'll have those notices out, but no, we're still on a roll, and we're getting into seabirds and loons in the next 2. With that, thank you so much, Jen. I'll hit the recording. If you want to stay on, Jen, for a sec when everybody goes, that'd be great.
Okay.
All right, I'm going to stop the recording.